Hello friends, today we will be doing Math Kangaroo level 5 and 6, year 2020, question 24. This is a 5-pointer question. Let's read the question. Which of the following options will definitely balance the third scale? So we have scale number 1, which is this. You have scale number 2, and we need to put something here so that they balance out. Now, if you see these connections in the first scale, you have the triangle and the arrow, which is equal to two circles and the square. And in the second one, you have three squares, which are equal to two triangles and the circle. So here what we can do is we can add both sides. So you get a triangle and an arrow plus three squares, which is equal to a square, two triangles, and three circles. Now, since they are equal, what we can do is we can cancel the square, we can cancel this triangle. So what we get here is, if you see, you get two squares and an arrow, which is equal to, which is this, which is equal to three circles and a triangle. So the answer option for this is option C. Let's do one more question. Let's read question number 25, which is again Math Kangaroo level 5 and 6, year 2020. The question reads as follows. 10 people each order one scoop of ice cream. They order 4 scoops of vanilla, 3 scoops of chocolate, 2 scoops of lemon, and 1 scoop of mango. They top the ice creams with 4 umbrellas, 3 cherries, 2 wafers, and 1 chocolate chip. They use one topping on each scoop such that no two ice creams are alike. Which of the following combination is not possible? Whenever we are doing these questions, please read that whether the question is asking for what is possible or what is not possible. A lot of time when you're doing it under exam pressure, a lot of kids just read it as possible and they get the first combination and they move on. So that's not how it has to be done. So we are looking for combination which is not possible. So they ordered 4 scoops of vanilla, 3 scoops of chocolate, 2 scoops of lemon, and 1 scoop of mango. So these are the 10 flavors of ice cream that they have, like 10 ice creams that they have ordered of different flavors. Now let's look at the topping. They use one topping on each scoop. Okay, so you have 4 umbrellas. We have 4 umbrellas. So what I'll do is we'll put one umbrella here. Let me use a different color. So they put one umbrella here. I'll put one umbrella here. I'll put one umbrella here. And I'll put one umbrella here. So all these 4 umbrellas have been placed on different flavored chocolates. Then you have the cherries. So you place the cherry on this one. You'll place the cherry on this one. You'll place the cherry on this one. Then you have the wafer. So you place this wafer here, you place this wafer here, and then you have this last chocolate chip. So all these 10 toppings have been put on 10 different ice cream scoops. So now what is not possible? Let's just check the options. Chocolate with a cherry. So we have a chocolate with a cherry, which is option A. So this is possible. Since this is possible, this is not my answer. Mango with an umbrella. So you have a mango with an umbrella, which is here. Then vanilla with an umbrella. So I do have vanilla with an umbrella. Lemon with a wafer. So now you only have 2 lemons, one with an umbrella, one with a cherry. And so this is not possible, lemon with a wafer, because we've not been able to find this. And then vanilla with a chocolate chip. So vanilla with a chocolate chip is right here, which is option E. So what option is not possible? It is option B, which is lemon with a wafer. Let's do one more question. Let's do question number 26 from the same paper. We call a 3-digit number nice if its middle digit is greater than the sum of its first and last digits. What is the largest possible number of consecutive nice 3-digit numbers? Consecutive means numbers which are coming one after the other. Like you have 2, 3, 4. 2, 3, 4 are consecutive. Even in this case, 1 is a consecutive. Like 1, 2, 3, 4 is also consecutive numbers. So the question here says it's nice if the middle digit is greater than the sum of its first and last digits. Like for example, you write 1, 3, 0. So in this case, 1 plus 0 is 1, which is less than 3. So the middle digit 3 is greater than the sum of the first and the last digit. Now we need to find consecutive numbers. Now, for example, if I do this, here it becomes 2, then I don't have, here it will become 3. So 3 will be equal to 3. So these are the consecutive numbers. But we need to find combination which gives me the maximum nice digits. So let's start with this 190, wherein 9 is greater than 1 plus 0. Then you do 191, 192, 193, 194, 5, 196, 197. Yeah, because you can't do 198 because if you do 198, this becomes 9 equals to 9. So hence this combination is not possible. All here, 1 plus 0 is less than 9. 1 plus 1 is less than 9. 1 plus 2, which is 3, is less than 9. 1 plus 3, which is 4, is less than 9. 1 plus 5 is less than 9. 1 plus 6, which is 7, is again less than 9. And 1 plus 7 is 8, which is less than 9. So this is not possible. So how many combinations possible? 1, 2, 3, 4, 5, 6, 7, and 8. So the answer for this is option D, which is 8. Let's move on. Let's do question 27. Magnus has to play 15 games in a chess tournament. At some point during the tournament, he has won half of the games that he has played. He has lost one third of the game. So he has actually won one half of the games and he has lost one third of the games that he has played. And the two have ended in a draw. How many games has Magnus still to play? Now here there's an important condition that number of games that the person has played has to be divisible by 2. So let's just read the option. So the question here is how many games he's still to play. So if he's still to play 2, so that means how many games he has played, which is 13. Now 13 is not divisible by 2, so this is not my answer option. You do 15 minus 3, which is 12. So 12 is divisible by 2 as well as by 3. So we'll keep this option. You do 15 minus 4, which is 11. Again, not divisible by 2 or divisible by 3. We do 15 minus 5, which is 10. Again, not divisible by 3, but divisible by 2. And 15 minus 6 is 9. 9 is not divisible by 2, but it is divisible by 3. So the answer option is B. But if you solve it, let's take 12 as the answer. So out of 12 games, they won half the game. So half of 12 is 6. So they have won half. Okay. And then out of them, they lost one third of 12, which is 4. And they drew 2 games, which is adding up to 12. 6 plus 4 plus 2 is 12, which is matching with this games played. So the answer for question 27 is option B, 3 games are yet to be played. I hope you understood these questions. If there is any question that you want me to solve, please leave a comment. Thank you for watching.